So when we look at it in the vertical direction, we need to pay attention now to opposing forces. So in the horizontal, we weren't looking at opposing forces, but in the vertical we are. So if I was to look at a circle going up and down like this, and I put my center in, if my object is at the top, so if we're thinking about spinning a bucket, remember the old trick where you can spin a bucket with water and not get wet? So when the bucket is up at the very top and it's tethered to a string, what we have is we have the force working towards the center, and we call it tension because we're working with it tethered to something. Okay. And what else is working in the vertical direction? Force of gravity. So now we can say force centripetal is the combination of two forces in the vertical. We have force tension and we have force gravity working in the same direction. They're not opposing each other. They're working in the same direction. So force tension is working towards the center of the vertical motion. Force gravity is working downwards. Check in the folder if you need the notes. Okay, if I was here in the bottom position, here's my object in the bottom position, which way is force tension going to work? Up. It's going to work towards the center of the spin. Which way is force gravity going to work? Down. Force gravity always works downwards. Okay? So if we had to write a sentence for that, we would say that the centripetal force is going to be equal to the force tension plus the negative force of gravity, because now they're working in opposite directions. Okay, and we're going to make this disclaimer here. Any force that's pulling, towards the center, so force tension in this case, and we always give it a positive. Okay? So any force that's working towards the center of a circular motion is always force centripetal. But in this particular case, you have force tension because you have the object at the end of the rope, and you have force gravity working. Okay? So when we look at a vertical circular problem, we want to look at the minimum speed. So remember when we were doing vertical motion, we looked at maximum height? Well, when we're looking in circular motion, we're going to look at minimum speed, and it's at the top of the circle. This is as slow as you can spin it before the rope crumples. Okay? So it doesn't leave it, it's the minimum speed it takes before that object can't stay in that circular path. So what we're going to say then is the tension in the string is going to be 0. Okay, so if we're looking for the minimum speed it takes to turn around, that's when force tension is equal to 0. If I had force tension being 0, what can I say about this? They're just equal. Force centripetal is equal to force of gravity. What's the formula to solve for force centripetal? It's which? Acceleration, centripetal acceleration. And what's the formula for force gravity? Mass times acceleration due to gravity. What is staying constant between these two formulas? Mass. We're not changing the object. How do we solve centripetal acceleration? What's the base one? V squared over r is equal to g, which means that v squared over r will be equal to 9.81 meters per second squared. Okay? So this is for minimum speed at the top of a circle. Okay? Minimum speed at the top of a circle. Force tension is 0. Just like what we said about maximum height. We said that the velocity would be equal to 0 at maximum height. It doesn't stay that way. It's like a blink of an eye and it's changing. But in that moment, that's where it's at. Let's look at an example. An object is swung in a vertical circle with a radius of 0.75 meters. What is the minimum speed needed to keep the object moving in a circular path? So we're going to draw a picture. We're going to put our center in there. What is 0.75? The radius. So that's this distance here. Okay. Minimum speed, that's code word for the object is at the top of the circle. Minimum speed means that it's at the top of the circle. When it's at the top of the circle, force tension is 0. So force centripetal is equal to force of gravity. So we're looking at v squared over r is equal to g. And it's asking us, what is the minimum speed? So of these three symbols, which one are we solving for? V. We're solving for v. So we have to move r out of the denominator. And then are we looking for v or are we looking for v squared? V. This is a step a lot of people will forget. We need to square root it. And what do we get for a value? 2 point what, Daniel? Blah, blah, blah. Thank you. What is the significant digits in this question, Avery? 2. So our answer is going to be V is equal to 2.7 meters per second. Now, which V is this? Is this speed or velocity? Speed. So do we need direction? No, it's scalar. Okay, a string requires a force greater than 135 newtons in order to break it. A 2-kilogram mass is tied to this string and whirled in a vertical circle with a radius of 1.1 meter. What is the maximum speed that this mass can be whirled without breaking the string? So if we were to draw this, if we find minimum speed at the top of the circle, where would we find maximum speed? The bottom. Okay, we find it at the bottom of the circle because this is where there's the greatest tension. Okay, so our object is here. Force tension then is going to be working which way? Towards the center. And force gravity is going to be working which way? Down, right? So then they're opposing forces. Force centripetal is equal to force tension plus negative force of gravity. Now in here, there's a bunch of different informations. When you go back and you're looking at the teacher notes and all you see is a capital T, know that I don't write just a capital T. I write force with a subscript capital T because we've just learned what capital T is, period. So now we've got in one unit, one symbol meaning two different things. So I separate that out and I put a capital F with a subscript capital T. But in the notes, it means the same thing as the capital T, okay? Just so you're not getting confused and you're like, where's this letter coming from? I make the distinction between force tension and period. Okay. Piece of information in this question, Paulina. Kyle? Cameron? What force would that be? Which force would we call that? Yeah, exactly. Okay. And it's asking us to find what, Daniel? Speed. So in order to find speed, typically we start with speed and we work backwards. Let's start backwards and work towards speed this time. So I need to find force centripetal, and I can find that where it's mass times acceleration due centripetal acceleration. And then we have an equal to force tension, which has been supplied to us. And then I'm going to subtract force of gravity. And how do I find force of gravity? Rayleigh, how do I find force of gravity? There you go. Okay. Now in the last example here, We said that we could cancel our masses out. Can we do that here? Princess is saying no. How come, Princess? Because 1 is negative? How about because we have this math function in there? We can't just divide things out. Okay, so we're going to leave that there. Do we have centripetal acceleration? No, we're looking for velocity, so we want this. We want this, v squared over r. Now we can rearrange everything if we want. How do I move r out of the denominator? How, Kyle? Multiply it out. All of that has to be. I can't just move it up to mgr because that's not mathematically correct. Force tension minus force gravity, that answer has to be multiplied by r. Okay, I'm looking for v. I'm going to move mass. And then I want just v, so I'm going to square root it all. And you will, when you solve it mathematically in your calculator, you will do it step by step. You will do force tension minus force gravity. Answer. Then you will multiply it by radius. Answer. Then you will divide it by mass. Answer. And then you will square root it. Or you will use brackets to the nth degree. Okay? So, Princess, I'm going to get you to calculate it, and Joyce, I'm going to get you to fact check it. Okay? So force gravity is working in the positive, force normal is the opposing. How do we find, it's asking us the magnitude of the normal force. So if I want to rearrange this equation to isolate force normal so that it's positive, we're going to have force gravity minus force centripetal. Okay, I add force normal to one side, I add it to the other side, I subtract force centripetal from one side, I subtract it on the other side. So force normal is what we're looking for. Force of gravity is solved by how? Mass times acceleration due to gravity. And how do I solve for force centripetal? Mass times centripetal acceleration. Okay. Whoops. I put force G, I want force N. I just wrote the wrong letter down. How do I solve for centripetal force with the information that's given to me? How do I solve for acceleration? V squared over R. So I'm going to go 826 times 9.81 minus 826 times 14.0 squared over 61. I'm highlighting the square because if you forget to square, it will give you a wrong answer, and that's a common error. So Daniel's going to calculate and Rayleigh's going to fact check. Hang on. So force normal you said is what, Daniel? Newtons. Princess, how many significant digits am I looking at? 3. 1, 2, 3. The 9's going to have an influence on the 4. But how do I set this with only 3 significant digits? How do I set this, Cedric? When I go back up to this question, what does the actual question say? What does it say? The question part. What is the magnitude of the normal force? Do we need a direction? No. Magnitude is strictly number.